Well, hello and welcome to Doc Ontko's physics lessons. Today what we're going to be doing is we're going to be looking at a simple example of the force on two charges, two electric charges, that is due to the charge on each one of the charges. All right, and so we're just going to keep it simple. We're going to have two charges. One's going to be a positive charge, one's going to be a negative charge. And the positive charge is going to have a value of 2 times 10 to the negative 8th coulombs. And the negative charge is going to have a value of negative 3 times 10 to the negative 8th coulombs. Okay, so there's a force that's going to be an attractive force between each of the charges. Right? And so the force that we're going to have, right, is an electric force. And I'm going to call this charge over here the positive charge 1, and the negative charge is going to be 2. And I'm interested in the force on the positive charge. Okay, the value of the force is going to be the same on each charge, but while the magnitude will be the same, the direction will be different. Excuse me. The direction of the force on the positive charge is going to be to the right. And the reason for that is because these are attractive charges, right? We have a negative charge on the right, a positive charge on the left. They're going to attract each other, so the positive charge is going to want to travel to the right, thus the force on the positive charge is also going to be to the right. So I've decided already on my direction of my force. Now I'm going to label the force, and I'm going to call it F12. And the reason that I do this is really for accounting purposes. And this is the force on charge 1 due to charge 2. All right? And I'm going to draw a little vector arrow up at the top of the force so that I know where this is going. The reason I do this is it's not quite as important for a problem where we only have two charges, but where we have 3 or 4 or 5 charges, it becomes more important to keep the accounting right. So I know when I get a calculation which force I've just calculated and what the direction of that force is. Okay, so I can sum them all up later as vectors and get some kind of a resultant. So I know my direction is to the right, and now I can calculate the force, the electric force on the positive charge. Well, the equation that we have is K times Q1 times Q2 divided by the distance between them squared. Well, I haven't said what the distance is, so we're going to call that 1 centimeter. So it's 1 centimeter between the two charges. All right, and so we can now plug in the values. Well, K is just Coulomb's constant, and so that's 8.98 times 10 to the 9th. All right, and we're going to leave the units out so that I can fit all this on the screen. Times Q1, which is 2 times 10 to the minus 8th coulombs. Again, we're going to leave the units out. Again, times 3 times 10 to the minus 8th coulombs, divided by the distance squared, and the distance is 1 centimeter. Don't forget to change that to meters. Now, you're going to notice that I've left the sign off of the charge on the right-hand side. This is negative 3 that we see up there, but I've left the negative sign out. Why did I leave the negative sign out? Because the answer that we're going to get, the sign of the answer that we're going to get here is really meaningless. You have to look at the situation that you've got, and you've got to look at the vector direction from the perspective of the charge that you're interested in. The vector direction from the positive charge is going to be traveling to the right. Well, if we were interested in the direction of the negative charge, that vector would be to the left. Okay? And so I could either have a force to the right or a force to the left by using the same values that I'm plugging in here. So does the negative sign on the minus 3 have any meaning? No, not really. What you've got to do is you've got to draw a picture, you've got to visualize it, and then decide on the direction of the vector. So when I plug these into my calculator, the answer I get is 5.38 times 10 to the negative 2 newtons. So that's the force on the positive charge due to the negative charge. That also is the force on the negative charge due to the positive charge. It would be an equal and an opposite direction based on Newton's first law. So I hope that helps. If you would like to see a more complicated problem, you can look at the charges in multiple dimensions where I have at least 3 charges or 4 charges, and we solve a problem doing that with vectors as well. Again, I hope that helps, and we'll see you next time.